This is Engage New York, Module 1, Lesson 11, Concept Development. All right, so we're going to take on 3 times 0.2 or 2/10. Now, what I want you to think about is what you know about arrays. So it's making copies. It's like you're taking something and you're making a copy of it. For instance, if I said, I have 3 and I have 3 groups of 3, or I have 3 copies, I have 3 copies of 3. We're going to use that idea as we talk about this concept. So, what number is this? This is just a 3 as a whole number, correct? Then we have our decimal of 2/10. So we're going to make 3 copies of 2/10. That is what we're going to do. So the repeated addition of this would be 0.2 plus 0.2 plus 0.2, because multiplication is really repeated addition. So in our place value chart here, we're going to do, here is 0.2. Here's 1 copy of 0.2. Here's another copy of 0.2. And here's another copy of 0.2. So if you add them up together, what do you end up with? You end up with 0.6, right? All right, so this with this will lead us here. So 2 times 3 is what? 6. 3 times 0 is 0. Now remember what we just learned in our video too, about when we're pretending, while we're multiplying, we're pretending that that decimal is really over here. And when we shift it once, we have to shift it back. So 0.2, there are 3 copies of 0.2. Here are 3 copies of 0.2. Here are 3 copies of 0.2. Give me a thumbs up and let me know how you're doing on this so far. Okay. All right, moving on. Now we're going to move on to 3 copies of 0.3. So what does that look like? 0.3 plus 0.3 plus 0.3. There are 3 copies of 0.3. Here we go. 1. Here's 1 copy. Here's 2 copies. Here are 3 copies of 0.3. You add them up and you end up with 0. What? 3 times 3 is 9. Now let's come over here. 3 times 3, remember we're going to pretend this is over here. We're going to shift it. It's like multiplying by 10, shifting it once. Then we're going to multiply. And now, because we shifted it over once, we have to shift it back. And we end up with 0.9. All right, next, we're going to 4 copies of 0.3. So let's write that out. Here's 0.3 plus 0.3 plus 0.3 plus 0.3. So I have 4 copies of 0.3. Now let's go ahead and put this in. 1, 2, 3. Here's another copy of it. Here's a 3rd copy of it. Here's a 4th copy of it. Now, wait a minute. What happens when I have more than 9? I have to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? I'm going to grab a pen that works. I'm going to grab this group right here, right? And you're going to move 10 over here. And now you have one, and you have 2 left over. So you're ending up with 1.2. Now let's come over here. Let's multiply this by 10 and just move the decimal over. Now we're going to go 3 times 4 is 12. 4 times 0 is 0, right? Now we're going to move that decimal back. Now we're going to divide by 10 and move the decimal back. And we end up with 1.2. And when you add up 0.3 plus 0.3 plus 0.3 plus 0.3, you end up with 12, carry the 1, 1.2. Do you see how all of this works together? Give me a thumbs up if you can see how this all works together. On. All right, now our numbers are going to get a little bit more complex. And now we have 4 different ways to model this problem. All right. We have standard algorithm, we have place value, we have breaking the numbers apart, and we also have repeated addition. There are 4 different ways to show how to multiply this decimal. So I'm going to make 2 copies of 0.43. So what does 0.43 look like in here? There's a 0, and there's 4 tenths, and there are 3 hundredths, correct? Now, that's 1 copy of it. Now, I'm going to make another copy of it. 4 and 1, 2, 3. I have 2 copies of 0.43 or 43 hundredths. Now, I'm going to go through and I'm going to add these. 1, 2, 3, 4, 5, 6. Okay, I'm all right. And 1, 2, 3, 4, 5, 6, 7, 8. I'm still okay. So my answer should end up being 0.86. So now let's write this another way. Here is, now I'm not sure if you remember how this is done. Let me stick with this and then we'll go here. So repeated addition, this is 0.43 plus 0.43 because I have 2 copies of 0.43. You're adding the same number over and over. And if I add 0.43 and 0.43, I should get 0.86. Okay, I got 0.86. Now, let's try standard algorithm. Now, if I move my decimal twice to get rid of it, I can go ahead and multiply. 3 times 2 is 6. 4 times 2 is 8. 2 times 0 is 0. Now, if I moved my decimal twice to get rid of it, I need to put it back twice because this is like multiplying by 10 to get rid of it. Now I have to divide, which is 100. Now I have to divide once, twice to put my number back. All right, next step is I have 4 tenths, or another way to write it is 4 over 1/10. And over here, I could write it as 3 over 100. Now, this is thinking about using the area model. Now, remember I showed you earlier, area model is length times width. Length times width. This is called area model. Okay, we're going to break this up. I'm going to have 2 copies of 43 hundredths. So let me do it this way. I'm going to do it section by section. It's almost like using the place value chart here, but using it in an area model format. 4 times 2 is 8, and I have 8 tenths. Now I have 2 times 3. This is 2 times 3 is 6, and I have hundreds, right? So now if I bring it out and I put it into a decimal, 0.8 plus 0.06, and I add them up, it's going to equal 0.86. Do all my numbers match? Give me a thumbs up if my numbers all match. So you already know how to use the place value chart. You know how to do standard algorithm. You know that multiplication is repeated addition. And this is our new factor right here using the area model. Area model goes up with just multiplying length times width, which gives us what is in the middle, which takes us back to 3rd grade and going and looking at an array. How much is in the middle? When you have 3 times 2, you have 6 in the middle. Okay? Now, moving on to problem 5. We have 2 copies of 0 and 423 hundredths. Thousands, sorry. 2 copies of 423 thousandths. So let's make 2 copies of 423 thousandths. So I have 0 ones. I have 4 tenths. I have 2 hundredths. And I have 3 thousandths. Now that's 1 copy. I need to make 2 copies of it. 1, 2, 3, 4. 1, 2. 1, 2, 3. Now I have 2 copies of 423 thousandths. Now let's go through and add them up. I end up with 6, 4, 1, 2, 3, 4, 5, 6, 7, 8. I end up with 8. So this should equal 2 copies of 423 thousandths should end up as 846 thousandths. Now let's check it out. Let's jump down to repeated addition. 0.423 plus 0.423. If you add them up, it should come to 0.846. Okay, we're on the right track. Now let's jump up to our standard algorithm, and we are going to move it once, twice, 3 times. Now you don't have to. You could just count how many numbers are behind the decimal. All right. So remember, you can pretend, you can at the end, after you finish solving, all you have to do is count how many numbers are behind the decimal and go ahead and add them back. Or you can pretend that you got them out of the way 3 times. Now, I added this back. 1, 2, 3. I took it out 1, 2, 3. I'm going to put it back 1, 2, 3. Now going to area model. Area model, I have 2 copies of 4 tenths, 2 hundredths, 3 thousandths. So 2 times 4 is 8 tenths, or you can write it in decimal form like 0.8. 2 times 2 is 4 hundredths, which is also 0.04. And then 3 times 2 is 6 thousandths, becomes 0.006. When you add them up, you end up with 0.846. All my numbers match. All right, moving on to problem 6. 4 copies of 4. Now we went from 2 copies to 4 copies. All right. Here we go. 4 times 0.423. So we have to make 4 copies of it. So I have 0 ones. 1, 2, 3, 4. 1, 2, 1, 2, 3. One copy. 0.1234. 1, 2, 1, 2, 3. Here is my third copy. 1, 2, 3, 4. 1, 2, 1, 2, 3. And now my fourth copy. 1, 2, 3, 4. 1, 2, 1, 2, 3. Now, if I add them up, which I don't really have very much room here. 1, 2, 3, 4. So if I just use the array, this is 3 by 4. 3 by 4 is 12. So I have to carry 1 over, right? I have to carry a 10 over. Then I'm going to end up with 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm using the array. 4 times 4 is 16. I'm going to have my 6 carry the 1, or you can grab 10 and pull it over and see what's left. Now, I want to make sure everyone is trying this. All right, now let's go down to our repeated addition. Okay, repeated addition is 0.423 plus 0.423 plus 0.423 plus 0.423. So this is 4 copies of 0.423. Let's come up here. Let's do standard algorithm. If you want to pretend 1, 2, 3, get it out of the way. Now, and then when you go back, you have to add it back. So 3 times 2 is 12. 4 times 2 is 8 plus 1 is 9. 4 times 4 is 16. 4 times 0 is 0. Now I have my number, but I took this, I multiplied by 1,000 to get rid of this. Now I have to divide by 1,000. So, do my numbers match so far? 1.692. 1.692. Okay. Now, 4 times 4 is 16 tenths. And we know what 16 tenths is. It's really 1.6, right? Then we have 2 times 4 is 8 hundredths. And then we have 3 times 4 is 12 thousandths. Now, I have to take this 1 and add it over here. So I end up with 0.02. No, tenths, hundredths out. I have another 2. I have another place value I need to add. Then I'm adding plus 1 here. So 8 hundredths. And then right here becomes 1.6. So add that together. I end up with 1.6. Oh, wait, I forgot to add the 1. 992. All right. Moving on to the next page. Probably the most difficult part of this is learning this new area model. You should be familiar with 6 copies of 1.21, repeated addition, standard algorithm, and then what is new is adding this area model. Okay, so now we have, instead of 2 copies, 3 copies, we have 6 copies of 1 and 21 hundredths. You'd have to, repeated addition, you would have to add this 6 times. On this problem here, you'd move it twice out of the way. Once you get your answer, you move it twice back into your problem. Area model, I'm going to focus on the area model for this next couple of problems so that you see how the area model works. So 1 times 6 is 6. because I have 6 copies of 1 is 6, correct? Then I have 6 copies of 2/10. 6 copies of 2/10. This would be 12 tenths, in which we know one of these, that 10 is going to have to move over here. Then we have 6 copies of 100. 6 copies of 100. So here, let's start at the end and move this way. So this would be 0.06 plus, now I have to take this 10 out and move it over, and I end up with 0.2 tenths. And I have to take this 1 and move it over, so it's plus 1. This should be 7. 7 and 26 hundredths. 7 and 26 hundredths. All right, remember, I'm concentrating on the area model because place value, making 6 copies and adding them up using standard algorithm, multiplying by 100 essentially to move it out of the way, and then dividing by 100 to put it back. Repeated addition, 6 copies of 1.21. All right, now 7 copies of 2 and 41 hundredths. So in the area model, the way I have it set up for you, it's 7 copies of 2 and 41 hundredths. So 7 times 2 is 14. 7 times 4 is 28 tenths. And then 7 times 1 is 7 hundredths. Now, starting on the right and moving across, we would have 0.07. Now, 28 tenths. 28 tenths. What am I going to do with 28 tenths? I have to move my 28 tenths right over. I have to move 2 tens over here. Making sense? Making sense or no? All right, moving 2 over here. I'm left with 8 tenths. Now I move this over, so it's 14 plus 2 is 16. So I end up with 16 and 87 hundredths. Last one, 8 copies of 2 and 34 hundredths. So 8 times 2 is 16. 8 times 3 is 24 tenths. And 8 times 4 is 32 hundredths. Now, I have to move the hundredths over. Okay, so I'm going to keep my 2, I keep wanting to do that, 2 hundredths. I'm going to move 3 over and make that 27. So it's going to be 7. I'm going to move 3 over, so I have to add 3. So this is 27. But 27, I'm going to keep the tenths, 7, take my 2, add it over here, and I'm going to end up with 18. 18 and 72 hundredths. All right, so for problem set, going through problem set, solve by drawing discs on a place value chart. Drawing discs on a place value chart. This is what they mean. Just doing this. That's all you have to do on these problems here. Then on problem 2, you're using the strategy we just worked on the area model to complete A and B. On the back side is the same thing. 3 copies of 4 and 65 hundredths. So draw the area model for these 2 problems. Then lastly, Miles incorrectly gave the product of this as this. Use the place value chart or one or the other, or an area model to help Miles understand his mistake. So you're basically explaining to Miles, what mistake he made. Finally, Mrs. Zamir wants to buy 8 protractors, and a protractor is what they use to measure angles, and some erasers for her classroom. She has $30. If protractors cost this amount, how much will Mrs. Zimmer have left to buy erasers? Now, I want you to think of the problem we did yesterday with how much, remember the marker, the problem with the pen and the marker. You're using your strategies on how much she can buy. Here. How much will Mrs. Zimmer have left? How much change will she have left to buy erasers after already purchasing the protractors? Okay. I'm sure you're going to do great.